So this is a PQ5. We are required to, given the values of a set of bivariate data composing of 10 observations of x and y, right? We need to sketch the scatter plot diagram. Okay, so after that, what we need to do is basically just key in the values, the best set of data. So we were looking at basically this question, all right? So we're looking at this question, which is the best set of data. So we're looking A, B, C. So here, since, there are a lot of ways to compare the model from data. One way is to look at the scatter diagram. Well, the second way is to use the value of R. And so since in part 1, they've already asked us to use the value of R, and this is what we're going to do in part 2. We're going to find the value of R here. So we're going to find the R value for B and the R value for C into the scatter diagram. Right, so very quickly, if you were to look at on the other side, this will be the what you key into the GC. Alright, so go to stat, go to this one, and then you key in all these values. Alright, you key in all these values at the start. This one, this 2, this 3, this one, this 2. Alright, this will be all your x values, and this will be all your y values. Alright, following which, after you key in, the next one will just be to go into the, okay, if you are interested in doing a scatter plot, what you can do is you can also store. Alright, you can actually store the y1, so you go to alpha trace and store your y1 here. Alright, so if you are not sure how to do this, I have another comprehensive video on how to create a new list. Right, the next one, just calculate your linear regression, go to 8, and then you have your R value easily. Right, so last one easily, what will be the next one? The next part of the question will be to sketch the scatter diagram. So which is just over here, which is negative 0.9728. Right, so the next part is now which are the follow, and how do we do? Go to step plot. Alright, go to step plot, make sure your plot is on, alright, put it in the GC. Alright, you should get your step plot, scatter plot easily, scatter diagram. If you can't see everything, just remember, go to zoom and press zoom step, which is option number 9. Alright, so you get a scatter diagram easily. Alright, it's just over here as we have found just now. So we will look at easy. Sure that you, okay, this is the answer scheme, that you remember the following, that you always label the first and last coordinate. We always use crosses, we don't use boxes. That's what we often see in the GC. Alright, label the origin, label the x and y axis. Alright, and to determine the value of the product moment correlation coefficient, which is the data. This is what we will. Alright, so basically for the second, we want to look at model B. Right, so how do we find the model B? Right, so we actually, model B will be y equals to cx squared plus d. So here's how we're going to do. We're actually going to create a new, not sure how to create a new list. You can actually look at my other videos. Right, there's one which I did want to create a new list. Alright, so what I do is very simple. I go to list 4, I go back to the list. Alright, I'll key in a new list here, list 4, which will actually be the sum or square of all the values in list 1. So remember, list 1 originally was our x1, right? So I'm going to key in then data by data 0.5. Because of this function, this will be 0.5 square. 1 will be given 1.1 square, 1.5 square, 2 square, 2.5 square. Right, so that's what I'm going to do. After that, I'll press enter, and this is what I will get. This is what I'll get eventually the list 4 to be my square of the data. So from here, right, remember just now we were doing the y equals to cx squared plus d. Remember, we were doing y equals to cx squared plus d, right? So based on this, right, so based on this x squared, this x squared is actually our list 4, because we keyed at list 4. This y is our list 2. Alright, so we'll use these values to do our correlation regression. We will find the value of R, and you see that the value of R for model B is negative 0.999. Now similarly for model C, remember our model C, what we'll do is we'll key in list 1. Okay, so you can see I'll key in list 1, list 5 as the square root of list 1. Why? Because you remember that our model C is nothing but y equals to e square root x plus f. So this will be our list 2, this will be our list 5, and that's what we're going to do. We're going to keep the list 5 as the square root of list 1. Alright, so it's a square root because this 1 is basically all our x values, and so this list 5 over here will be the square root of this 1. Alright, so that's what we're going to do. Okay, after that, after which I'm going to put it away, this will be the list 5. Alright, so doing linear regression, now remember that this is originally our square root of x. Okay, this one will be the y. So what are we doing? We are actually finding the regression line of y equals to e square root x plus f, which is our model C, and we're going to calculate the r value. Alright, so press calculate, and this is what you have. The r should be equal to negative 0.930. Okay, so in part 2 now, we determine which is the best correlation coefficient. Okay, right, so you observe the a over here has the value of negative 0.97. Alright, this one is basically your a, right? So this over here, this is for a, this is for b, and this is for c. And you can see the best model should be the one with an absolute value that's closest to 1. Right? So very evident that just by comparing the r value, you can see that in our question, right, r equals to negative 0.9. So model B, in fact, is the best model for the to represent this set of data, to do the regression line for this set of data, because it has a absolute value that's closest to 1. Right, it's the best model for this set of data. All right. So with that, we're going to use model B. All right, we're going to use model B as our estimate. Right, so we're going to write down here the regression line based on, all right, based on this estimate. So our regression line, so we're now answering part 3 already. So part 3 will give us, our regression line for model B. It's just y equals to negative 0.35897x plus 13.22512821. Alright, that is our regression. That's the equation of the least square regression line of our model in part 2, which is B. Right, so it's in B. Okay, so this is the regression line. We are answering part 3. And based on this, okay, I'm sure you know how to do. So basically, we just submit x equals to 8. You can even use your GC, just calculate value, go to x equals to 8. Alright, so I made a mistake here. This should be x squared, not x all, because we are using model B. Just based on regression line, just repeat again your regression line. If I were to write it in intrinsic form, this will be negative 0.359 x squared. Remember, it's not x, plus 13.2. Okay, so x squared plus 13.2, this is correct to 3SF. Right, then basically if I submit x equals to 3.8, I'm sure you can calculate it by yourself. Y is equals to about 8, approximately 8.0415, which is just 8.04 3SF. Alright, okay, the next part, I'm going to use the equation to estimate the value of y. Alright, so the estimate the value of y when x is equals to 3.8